In the second half of 1942, it became obvious that the twin-engine Ki-45 Toryū fighter would soon struggle. This aircraft was serving with the Imperial Japanese Army Air Force at the time. It was clear it would soon fail to keep up with the harsh realities of modern air combat. By August of that year, Kawasaki's management initiated a major modernization program for the aircraft. The company's chief designer, Takeo Doi, took on the task of developing a significantly improved version of the fighter. The plan was to equip the new aircraft with powerful Mitsubishi Hi-112 engines. Each engine would produce 1,500 horsepower. Compared to its predecessor, the updated aircraft featured slightly modified airframe dimensions. Specifically, the wingspan was stretched to over 51 feet. The tail surface area was also enlarged. The engineers hoped these changes would improve the aircraft's handling. They also wanted to significantly boost its overall flight performance. Kawasaki's ambitious project quickly got the green light from the technical department of the Army Air Headquarters. Soon after, the military ordered the construction of 3 prototypes, but military requirements can be fickle. By December 1942, the High Command completely overhauled their specifications. Now, the Army ordered Kawasaki's designers to create an entirely new single-seat fighter. Naturally, such abrupt changes caused serious delays. The design had to be rebuilt basically from scratch. It was not until September 1943 that the new prototype was finally rolled out for initial testing. This was a twin-engine, single-seat fighter. It was designated as the Ki-96. The 3 prototypes demonstrated solid flight characteristics for the time. They also carried some seriously heavy armament. You would think they were ready to go straight into mass production. However, toward the end of 1943, the strategic situation in the Pacific Theater had changed drastically. This change was not in Japan's favor. Under these new conditions, a twin-engine, single-seat fighter with no rear gunner or defensive armament was a problem. It no longer seemed like a practical solution to the military. Because of this, the aircraft's requirements were rewritten yet again. This time around, the new technical specifications demanded a versatile 2-seat aircraft. It needed to be a true multi-role fighter. It had to be capable of striking enemy ships as an attack aircraft. It needed to do this just as effectively as it could operate as a high-altitude interceptor. Right around this time, Japanese intelligence got word of the new American B-29 heavy bomber. Developing an aircraft that could effectively counter this formidable new threat instantly became Japan's top priority. To find the perfect weapon against the American bombers, the Army Command looked at 2 entirely different approaches. The first option involved creating a relatively light, single-engine interceptor. It would be armed with 2 30mm cannons and 2 20mm cannons. Eventually, this concept came to life in the form of the Nakajima Ki-87 and Tachikawa Ki-94 high-altitude fighters. However, neither of these aircraft made it into active service before the end of the war. The second approach focused on the concept of a heavy twin-engine interceptor. This aircraft would carry much heavier firepower. This meant massive cannons ranging from 37mm to 57mm in caliber. But regardless of the chosen path, both concepts had one non-negotiable requirement. The future interceptor had to operate reliably at extreme altitudes. This meant heights of around 32,800 feet. And to keep the engines from starving for oxygen in the thin air, the designers absolutely had to incorporate complex turbochargers. Jumping ahead a bit, Japanese industry was dealing with a serious technological gap at the time. This was especially true when it came to developing and manufacturing turbochargers. That same bottleneck killed a lot of otherwise promising Japanese aviation programs. Kawasaki, a company we are already familiar with, took the lead on the heavy twin-engine interceptor. At the time, their engineers had the most experience in this specific area. They also had a solid foundation of existing R&D carried over from the Ki-96 fighter project. A little later, the Army Aero Technical Research Institute stepped in. They were also known as Rikugun Kokugijutsu Kenkyujo. They brought their own design for a versatile heavy interceptor and ground attack aircraft. Their team developed a design for a highly promising aircraft. This aircraft received the designation Ki-93. Mitsubishi did not stay on the sidelines either. They developed their own twin-engine fighter, the Ki-83. It featured remarkably clean and highly refined aerodynamics. Although originally designed as a long-range escort fighter, its outstanding flight performance and heavy firepower gave the military real hope. They believed the airframe could be adapted into a top-tier high-altitude interceptor. However, as we have mentioned before, there were massive struggles with developing and mass-producing high-altitude turbocharged engines. These struggles proved fatal to all these ambitious plans. Not a single one of these ambitious programs reached full combat readiness before the war came to an end. The only exception was Kawasaki's project. After receiving a new set of requirements in April 1943, chief designer Takeo Doi jumped right into the work. His deputy on the project was Takeshi Nemoto. They used the already completed Ki-96 fighter design as the foundation for the new aircraft. This new aircraft was designated the Ki-102. The designers borrowed the airframe almost completely from that earlier fighter. Taking the Army Command's requests into account, Takeo Doi developed two different variants of the aircraft right from the start. He simultaneously designed a heavily armed ground attack aircraft and a high-altitude interceptor. Initially, the two variants were supposed to differ only in their engines. For the interceptor, they planned to use the 14-cylinder air-cooled Mitsubishi Ha-112 engine. This engine was fitted with an Ru-102 turbocharger. For the ground attack aircraft, however, they decided to install the standard, non-turbocharged version of that exact same Ha-112 engine. Both variants produced the same takeoff rating of 1,500 horsepower. However, the standard engine put out 1,250 horsepower at around 19,000 feet. The turbocharged version, on the other hand, maintained that power output up to nearly 27,000 feet. It continued to deliver 1,100 horsepower even when the aircraft climbed to 37,500 feet. The initial armament was meant to be carried over directly from the Ki-96 project. This setup included one large 37mm Ho-203 cannon and two 20mm Ho-5 cannons. Later on, though, they decided to significantly beef up the firepower. Instead of the previous main gun, the aircraft was fitted with a new, much larger weapon. This was the 57mm Ho-401 cannon. The 20mm cannons were left right where they were. But to protect the rear, a 12.7mm Ho-103 machine gun was mounted in the gunner's cockpit. This new 57mm Ho-401 cannon packed incredible destructive power. However, since it was basically just a scaled-up copy of its predecessor, it inherited all of its design flaws. Because of its short barrel and relatively weak cartridge, it had a very low muzzle velocity. This resulted in a heavily arcing trajectory. It made the effective firing range extremely short. For the attack version of the Ki-102, which was meant to hunt down small enemy ships, this was not a critical problem. But for the interceptor, it was an absolute disaster. After all, its main job was to attack heavy bombers from a distance. It needed to stay safely out of range of their defensive gunners. Because of the short range, all the advantages of that massive caliber were completely negated. That is exactly why they decided to swap the guns on the Ki-102 interceptor variant. They went with the Ho-204 cannon. This was a 37mm weapon that was a bit less destructive. However, it had a much better range and rate of fire. It allowed pilots to lay down accurate fire from over 3,300 feet away. This kept them safely out of reach of the bomber's defensive machine guns. Overall, the design phase for the aircraft wrapped up by August 1943. Right after that, the Kawasaki plant in Gifu started building the first 8 prototypes. They actually split the order. The first 3 prototypes were built as high-altitude interceptors under the Ki-102 designation. The next 3 airframes, numbers 4 through 6, were built as Ki-102B heavy attackers. They later decided to use the last 2 prototypes, the 7th and 8th. These would serve as the foundation for an even more advanced single-seat interceptor called the Ki-108. It was essentially a direct copy of the Ki-102 design. But it featured a pressurized cabin for high-altitude flight and a slightly redesigned tail section. The Japanese High Command gave top priority to the Ki-102A interceptor. However, engineers kept running into technical headaches with its complicated turbocharger system. This really delayed the program. As a result, the Ki-102B attacker prototypes, which were being built alongside them, were ready for testing much earlier. The thing is, the base Mitsubishi Ha-112 engine was already a proven, reliable design. In various modifications, it was already being mass-produced for naval aviation as the Mk-8 Kinsei. Thanks to this battle-tested technology, the Attacker project did not run into any major roadblocks. The Ki-102B Attacker prototype made its maiden flight from Fusa Air Base in the middle of summer in July 1944. Naturally, the initial flight tests were not without the usual teething problems you would expect from a new aircraft. For instance, test pilots noticed a sharp drop in speed at certain propeller pitch angles. On top of that, the aircraft had poor glide performance during landing approaches. But despite these quirks, the overall impression of the new aircraft was genuinely positive. The designers quickly ironed out these flaws and made the necessary tweaks on the later prototypes. Most notably, they did this by significantly increasing the elevator area to make it smoother and more controllable. By October 1944, all necessary testing was successfully completed. The new aircraft was officially adopted into service as the Army Type 4 assault plane. By the end of that same year, the Kawasaki plant in Akashi managed to assemble the first pre-production batch. This consisted of just 20 attack aircraft. Production spooled up painfully slowly. It was constantly bogged down by devastating Allied bombing raids on the factory. On top of that, the plant was heavily tied up with another project, the Ki-100 fighter. The military high command considered this a much higher priority. Ultimately, by the time production completely shut down, the Japanese had only managed to roll out 238 of these aircraft. This number also includes the very first prototypes. As for the Ki-102A interceptor prototype, it was completed by June 1944. In August, they started putting the aircraft through aggressive flight testing, but the program kept hitting delays due to serious technical issues with its turbocharger. Despite the best efforts of the engineers, they only managed to build 5 experimental Ki-102A models by the end of the year. They never fully sorted out the engine problems. Because of this, they eventually started converting already completed Ki-102B production attack aircraft into the Ki-102, a variant. Historians still debate the details of this upgrade. It is not entirely clear if they fitted the upgraded He-112 engine into these modified aircraft, or if they just kept the standard power plant. It is entirely possible that the whole conversion just came down to swapping out the old Ho-401 cannons for the more powerful Ho-204s. Whatever the case, by the end of the war, they only managed to complete 25 Ki-102A interceptors. And even though some sources throw around a number of about 50 aircraft, we know this for a fact. In the summer of 1945, no more than 15 airframes actually entered service with the 28th Air Defense Regiment. This unit was based in the city of Togane in Chiba Prefecture. Up until that point, their primary aircraft had been the Ki-46 interceptor. The pilots of the regiment welcomed the new aircraft with tremendous enthusiasm. Even without a fully functioning turbocharger, the new Ki-102A climbed significantly faster. It could also reach much higher altitudes than their older reconnaissance-based interceptors. But most importantly, the aircraft stood out for its excellent armor, great survivability, and devastating firepower. This gave the crews total confidence. We know very little about how these production interceptors actually performed in real combat. This is because they entered service far too late. The prototypes themselves, however, did get a taste of action. They were stationed at the Fusa Army Aviation Test Airfield. There, they were often scrambled on actual combat air patrols over the Fusa area. One of these engagements took place on November 1, 1944. Flying the experimental aircraft was an experienced test pilot, Major Yasuhiko Kuroe. He attempted to intercept an American F-13A photo reconnaissance aircraft. It was circling right over Tokyo at an extreme altitude of nearly 32,000 feet. It is worth pointing out that Major Yasuhiko Kuroe was far from a rookie. He was actually considered the second highest-scoring fighter ace in the entire Imperial Japanese Army Air Force. By the end of the war, he had 51 confirmed aerial victories under his belt. On this occasion, however, his luck was not on his side. A sudden turbocharger failure prevented the Japanese ace from getting into a good attack position. The American crew, commanded by Captain Ralph Stakely, managed to slip right out of the trap and escape unharmed. The next major engagement happened during the infamous massive firebombing of Tokyo. This took place on the night of March 9th to the 10th, 1945. That horrific night, at least 80,000 residents of the Japanese capital lost their lives in the firestorm. Only 2 Ki-102A interceptors took part in fighting off this devastating attack. They scrambled into the sky from Fusa Air Base, and once again, Yasuhiko Kuroe was at the controls of one of them. Since these Japanese aircraft were not equipped with onboard radar, operating them at night was brutally difficult and largely ineffective. They were essentially flying blind. Despite these challenges, after a tough battle, Yasuhiko Kuroe officially claimed to have personally shot down 2 American B-29 bombers. Unfortunately, the identities of the second Ki-102 crew have been lost to history. They completely disappeared in the night sky during that sortie. As for those claimed kills, the Americans actually did lose 14 of their bombers that day. However, determining exactly which ones were shot down by the Japanese interceptors is simply impossible today. The Allies, for their part, had already given the Ki-102 its own reporting name, Randy. The Ki-102B attack variant had a bit more luck. This version was designed specifically to hunt down amphibious landing ships. The numerous Allied landings on Pacific Islands caused serious concern for the Japanese High Command. They realized something simple. Enemy landing forces were at their most vulnerable right at the moment they were disembarking from small vessels like LSTs, LSIs, and LSMs. Since these smaller ships lacked heavy anti-aircraft fire, attacking them from the air was relatively safe. As a result, the new attack aircraft was optimized specifically for this mission profile. Its main weapon was the powerful 57mm Ho-401 cannon. Ammunition capacity was very low, just 16 or 17 rounds, but the shells weighed about 3 1/3 pounds each. They came in both armor-piercing and high-explosive variants and hit with devastating effect. Furthermore, the rate of fire was an impressive 80 rounds per minute. For secondary firepower, the aircraft was fitted with 2 20mm Ho-5 cannons. Each was provided with 200 rounds per gun. When it came to bombs, the attack aircraft could carry up to 800 kilograms of payload. Loadouts varied. It could carry 4 50-kilogram bombs, that's about 110 pounds each, or 4 100-kilogram bombs, mounted in pairs under the fuselage. Alternatively, it could carry 2 larger 250-kilogram bombs. If needed, the aircraft could haul a single heavy 500-kilogram bomb on the centerline pylon. It could also carry a specialized 800-kilogram naval bomb. Eventually, the primary weapon for the Randy was intended to be the radio-guided Kawasaki Ki-102 glide bomb. Conceptually, it was very similar to the German Henschel H's 293. The weapon weighed 800 kilograms with a 300-kilogram warhead. Its Mitsubishi rocket motor ran on hydrogen peroxide for 80 seconds. This accelerated the missile to an impressive 340 miles per hour. Testing for this cutting-edge weapon began in the summer of 1944. It was tested on Ki-48 and Ki-67 bombers. But the Japanese simply ran out of time to finish development. While some sources claim these missiles were also tested on the Ki-102, there is zero documentary evidence to back that up. The aircraft used as interceptors for air defense were equipped with special air-to-air cluster bombs. These weighed 15 or 35 kilograms. Inside these canisters were 30 to 76 sub-munitions. Each weighed about 300 grams and was packed with high explosives. The military theorized that dropping one of these clusters into a tight formation of enemy bombers would guarantee the destruction of at least one aircraft. However, in actual combat, despite dropping them frequently, pilots quickly realized that a good burst of cannon fire was far more effective. The armor protection on the Ki-102 attack aircraft deserves special mention. For its time, the aircraft was exceptionally well protected, and not just by Japanese standards, but compared to anything flying worldwide. Up in the nose, the cannon bay was shielded by 2 steel plates. The front plate was 12 millimeters thick. The rear plate was 8 millimeters. The pilot essentially sat inside a flying fortress. His seatback and headrest were made from 12mm steel. 8mm plates protected his sides. On top of that, the pilot was covered from the front by a massive 60mm pane of bulletproof glass. Plus, there was another 8mm armor plate sitting right under the seat. The fuel system was also exceptionally well designed. Each wing housed 3 tanks. These held 75, 45, and 21 gallons. They were all lined with self-sealing material. They were also hooked up to an automatic fire extinguishing system. The main fuselage tank held 190 gallons of fuel right between the pilot and the rear gunner. It was solidly protected by 12mm armor plates on the front and back. It also had rubber protection on the bottom and sides. Even better, as the fuel burned off, the empty space was automatically flooded with carbon dioxide. This prevented fuel vapors from exploding. The rear gunner was not forgotten either. He was guarded by 3 armor plates. These ranged from 8 to 12mm thick. Thanks to all these engineering choices, the total armor weight on the Ki-102 reached 507 pounds. This made the attack aircraft a genuinely tough nut to bring down. Deliveries of the new Ki-102 to frontline units came very late in the war. They did not begin until the spring of 1945. The 45th Air Group, based at Hokota Air Base, was the first to receive these highly anticipated aircraft in March. Before this, their pilots had been flying Ki-36 and Ki-51 light attack aircraft. They also flew Ki-48 bombers and Ki-45 twin-engine heavy fighters. Interestingly, this specific unit became the only one where the Randy, which was the Allied reporting name for the aircraft, was actually used in combat for its intended purpose. During the intense defensive battles for Okinawa, a number of these aircraft were used in kamikaze attacks, what the Japanese military called special attacks. This happened as part of Operation Kikusui, which translates to floating chrysanthemum. During April and May of 1945, Japanese kamikaze pilots carried out desperate, massive strikes against the Allied invasion fleet. In these suicide missions, a handful of these Randy attack aircraft were used both as conventional bombers and as ramming aircraft. We know that at least one Ki-102 pilot, Shinbu Ryo, managed to survive one of these raids on April 12, 1945. At the last moment, he aborted the suicide attack. He successfully ditched his aircraft in the water and was later taken prisoner. In April of that same year, the 3rd Air Group, stationed in northern Honshu, also began re-equipping. Pilots started transitioning from their old Ki-48 Lily bombers to the brand new Ki-102. In fact, this became the only Japanese aviation unit fully equipped with these modern aircraft. However, they were never destined to see actual combat. The High Command held the pilots in deep reserve. They wanted to prepare for the inevitable Allied invasion of the Japanese home islands. Ki-102s from the 75th Air Group, based at the very northern tip of Honshu, were held in a similar reserve. Initially, this unit flew obsolete Ki-48 bombers. Their transition to the more powerful attack aircraft was in full swing, but it was never completed before the war ended. A few more Ki-102s were handed over to the 82nd Reconnaissance Squadron. Its core fleet consisted of Ki-46 Dyna reconnaissance planes. In the summer of 1945, this unit operated from airfields in Nanking and on the Korean Peninsula. This was as part of the 13th Air Division. Exactly what missions the new attack aircraft flew there is unfortunately lost to history. We also do not know how many were actually operational, as no precise records survived. In the final stages of the war, these aircraft were assigned to the 101st Fighter Regiment. This time, they were serving as interceptors. A photograph of at least one Randy wearing this unit's emblem survives today. It was taken by the Allies after Japan's surrender at an airfield near Osaka. This regiment was primarily equipped with Ki-84 fighters. They received a batch of these attack aircraft simply to help offset heavy combat losses. Thanks to their high speed and extremely heavy armament, Ki-102s had great potential as effective bomber hunters during low-altitude interceptions. American crews later shifted their tactics and began dropping bombs from lower altitudes. When they did, their strategic bombers once again became vulnerable to Japanese air defenses. A prime example was the massive raid on the Osaka-Nagoya industrial area on June 26, 1945. That day, 426 B-29 bombers sortied. The Randys of the 101st Regiment scrambled to intercept them. A lieutenant by the name of Shimamura managed to close in on one of the American superfortresses. According to his account, he scored a direct hit on the bomber's right outboard engine. The massive 57mm shell literally tore off the engine, along with a large chunk of the wing. After this, the fire spread to the adjacent inboard engine. The burning B-29 went into a steep dive. The Japanese pilot lost sight of it. Because of this, he modestly claimed it only as a probable kill. American records show that the U.S. did indeed lose 6 superfortresses that day. Aside from the 101st Regiment, aviation historian René Francillon notes something else. He states that Randy attack aircraft were also assigned to the 27th Independent Squadron. However, no detailed reports or specifics about this unit's combat record survive today. One of the top priorities in developing the Ki-102 attack aircraft was improving its fighter variant to make it even more lethal. The creation of a high-altitude fighter with a pressurized cabin went hand in hand with the development of the baseline Ki-102A and Ki-102B models. This eventually evolved into a completely independent and ambitious project known as the Ki-108. Meanwhile, work on the night fighter variant, designated the Ki-102C, was a logical continuation of the ideas introduced in the original design. The team led by the talented engineer Takeo Doi took on the development of this night fighter in early 1945. To avoid wasting precious time, they used the existing airframe as a baseline. They powered it with upgraded Mitsubishi Ha-112-2 Ru high-altitude engines. However, through this extensive modernization process, what essentially emerged was a completely new aircraft. To install the Taki-1 airborne radar, engineers had to completely strip the nose of its armament. Instead, 2 powerful 30mm Ho-155 cannons were mounted in the wing roots. Meanwhile, 2 20mm Ho-5 cannons were retained in their standard position under the nose. On top of that, they planned to mount 1 or 2 upward-firing 30mm cannons in the fuselage right behind the pilot. The radar itself was housed under a transparent plexiglass radome. Since the radar set was quite heavy, the designers had to significantly lengthen the fuselage. They also completely redesigned the tail surfaces and increased the overall wing area. They decided to eliminate the traditional rear gunner's position. Since the aircraft was meant to operate under the cover of darkness, rear defense was deemed less critical. The second crew member now took on the role of radar operator. His station was relocated to the rear fuselage. The canopy barely protruded above the aircraft's lines, featuring only a small glass blister for visibility. Work on the Ki-102C project moved painfully slowly. The process was constantly bogged down by endless Allied air raids. These raids were decimating Japan's industrial infrastructure. Plus, Takeo Doi's engineering team had to keep shifting their attention back to the Ki-100 fighter program. The High Command considered this a much higher priority. Interestingly, the first 2 prototypes of the night interceptor were not built from scratch. Instead, they were converted from existing production airframes of the Ki-102B Randy attack aircraft. The first test flight was scheduled for July 1945. The second prototype was slated to fly that August. However, events dictated otherwise. Just as the aircraft were sitting on the tarmac practically ready for their maiden flights, another massive bombing raid dealt them critical damage. The airframes were rushed back into the shops for extensive repairs, but they would never be completed. Japan's surrender brought the program to a definitive halt. Chief designer Takeo Doi had some truly ambitious plans. He wanted to combine the best technological features from the high-altitude Ki-108. Specifically, he wanted to use its pressurized cabin alongside the night fighting capabilities of the Ki-102C. The result was supposed to be the ultimate all-weather interceptor, the Ki-108 Kai. But by then, time had already run out for Japanese designers. By the end of the war, this project remained entirely on the drawing board. Overall, the Kawasaki Ki-102 was arguably the most heavily armed and well-protected combat aircraft in the entire Japanese arsenal. Yet its service history was tragically cut short. This powerful heavy fighter barely saw any real combat. Even if the Allies had been forced to launch a full-scale invasion of the Japanese home islands, the tiny number of combat-ready Randys would hardly have turned the tide. They simply would have been swept from the skies by the overwhelming numerical superiority of the enemy. When the war ended and Japan surrendered, a good number of brand-new Ki-102s fell into Allied hands intact. They were captured right on the Gifu factory floor before they even reached combat units. The post-war fate of these aircraft was entirely unceremonious. Most were simply towed away to massive scrapyards alongside other captured equipment. Only a handful of examples were hand-picked by the victors for detailed flight testing and evaluation. Ultimately, the Allies did not uncover any major technological breakthroughs. Soon, these unique aircraft were also sent to the scrap heap. Much to the dismay of modern aviation historians, not a single example of the Randy survives today. Under the skin, the Ki-102 was structurally a classic all-metal monoplane for its era. Its wing sat somewhere between a mid-wing and low-wing arrangement. This gave the aircraft excellent balance and flight characteristics. The wing was built around two main spars. One fascinating engineering quirk was designed to counteract the engine torque from those heavy, spinning propellers. The left wing was actually built just over an inch longer than the right one. Because of this asymmetry, the internal structure of the left wing featured 24 ribs. Meanwhile, the right wing got by with just 23. The fuel system was well thought out and heavily protected. Out in the outer wing sections, safely tucked between the spars, sat two self-sealing tanks. Each held about 45 gallons of fuel. Closer to the wing roots were two larger 75-gallon tanks. Finally, in the forward section of the center wing segment, engineers managed to squeeze in two additional tanks. These held about 21 gallons apiece. The main fuel supply, however, was kept in a massive 190-gallon tank located right in the fuselage, separating the pilot and gunner's stations. The main structural beams ran right through the fuselage on either side of this tank. Securely attached to them were two massive armor plates, each nearly 12 millimeters thick. These steel plates pulled double duty. They didn't just protect the crew from enemy fire. They also acted as solid firewalls, keeping the airmen safe in the event of a fuel fire. On the trailing edge of the wing, engineers placed flaps that were securely mounted on four reinforced hinges. Hydraulically actuated, they could smoothly deploy to an angle of up to 50 degrees. Interestingly enough, during a diving attack, these flaps doubled as highly effective dive brakes. This helped the pilot maintain control of the aircraft. The aircraft itself was cleared to dive at angles up to 60 degrees. It reached never-exceed speeds of up to 447 miles per hour. The landing gear featured a conventional tailwheel layout. The main wheels retracted backward right into the engine nacelles. On the early production models, the tailwheel also retracted into a dedicated tailwheel bay. It was completely enclosed by doors. On later versions, however, the designers decided to lengthen the tailwheel strut. They did this to provide clearance for carrying much larger and more destructive bombs under the aircraft's belly. Because of these changes, the doors were removed entirely. The tailwheel no longer retracted, remaining fixed in the down position for the entire flight. The heart of the aircraft was a pair of powerful 14-cylinder twin-row, air-cooled Mitsubishi Ha-112 Mark II engines. On takeoff, each one cranked out a solid 1,500 horsepower. At sea level, their operating output sat at 1,400 horsepower at 2,600 RPM. As the fighter climbed, performance predictably dropped off a bit. At 6,500 feet, the engine made 1,350 horsepower. At 19,000 feet, it was down to 1,250. But there was also a dedicated high-altitude fighter version of the aircraft, known as the Ki-102A. Its engines were additionally equipped with a Ru-102 turbocharger. Thanks to this upgrade, the aircraft maintained 1,250 horsepower even at 26,900 feet. And up at an extreme 37,400 feet, it was still putting out 1,100 horsepower. Each engine drove a reliable, metal, three-blade variable pitch propeller through a planetary reduction gear to maintain optimal flight efficiency. Early in production, two common exhaust manifolds were used, but engineers later swapped them out for individual exhaust ejector stacks for each cylinder. This made the design even more efficient. Now let's get to the best part, the armament. The main gun on the attack version was the devastating 57mm Ho-401 cannon. It was cleverly mounted right inside the nose of the fuselage. Because of this, only the very tip of the barrel and the muzzle brake protruded. To protect this weapon, a solid armor plate almost 12 millimeters thick was installed right in front of its drum magazine. The cannon's barrel ran through a custom cutout in this armor. Just behind the gun, they added another armor plate, 8 millimeters thick. Here, the weapon was securely bolted down with two massive brackets. Right under the breech of the cannon, they included a dedicated compartment to collect spent shell casings. Ammunition was stored in a unique drum magazine holding 16 rounds. There was also the option to load an additional round in the chamber. The gun featured a pneumatic reloading system. It fired high explosive and armor-piercing shells weighing about 3 1/3 pounds each. While the weapon could technically fire up to 80 rounds per minute, in real combat, that number rarely exceeded 50. And honestly, even that was overkill. The incredible recoil generated over a ton of force and shook the aircraft violently. Because of this, making more than one consecutive aimed shot was practically impossible. But that's not all. Just behind the cockpit, in the lower fuselage, they mounted two 20mm HO-5 cannons. Right above them were spacious ammunition boxes holding 200 rounds per gun. The feed was mirrored, left gun fed from the left, right gun from the right. Spent casings weren't retained. After firing, they were simply dumped overboard through special ejection chutes in the belly. The barrels of these cannons ran through long blast tubes and exited just under the aircraft's nose. These guns packed a serious punch and were capable of firing up to 820 rounds per minute. However, they were typically tuned closer to 700 to keep the weapons from overheating. To defend against fighters on their tail, a 12.7mm HO-103 heavy machine gun sat on a flexible mount in the gunner's station. During cruising flight, it was stowed beneath an aerodynamic fairing, but as soon as a threat appeared from the rear, the gunner could quickly flip this fairing open and engage pursuers. The ammunition supply was 200 rounds. It is worth noting that on fighter variants of the aircraft, this rear machine gun was often removed completely to save weight. As for the Ki-102A interceptor variant, the standard cannons were swapped out for a much heavier 37mm HO-204 cannon. This gun was nearly 20 inches longer. Because of this, its massive barrel extended noticeably far out of the aircraft's nose. Rounds were fed using a disintegrating metal link belt. Designers placed the 35-round ammo box directly above the weapon. The ammunition consisted of high explosive and high explosive incendiary shells. Each shell weighed just over a pound. Armed with this, the interceptor could deliver devastating firepower at up to 400 rounds per minute. When it came to the bomb load, ordnance was carried entirely externally. Under the belly of the fuselage sat two universal pylons. They were mounted side by side to carry smaller 250-kilogram bombs. But if a combat mission required a heavier payload, they used a single centerline pylon. This pylon was capable of handling a heavy 500 or 800 kilogram aerial bomb.